Hi everyone, today's lesson is for Algebra 2 honors students. This is chapter 5 of Quadratics and day 1. So let's get started. First, we have a lot of learning targets, and mostly what these are we're going to be learning today how to graph a quadratic, either by plotting points or by completing the square to find the vertex, and also finding some of the components that are also important in a quadratic. So basically for quadratics, something that you do need to know is that you have a general equation, which is right here, y equals ax squared plus bx plus c. A, b, and c are constants. One thing that is unique is that for sure a cannot equal to 0, because if a was 0, that would take this first term and that would be 0, and therefore you would have bx plus c, which would just be a linear equation and not a quadratic. You've got two types that we are going to be talking about today of quadratics. We've got the positive quadratic that comes up like this, it's positive, and then we've got the negative quadratic that has the negative sign in front of the x squared, and that's going to be going upside down. Some vocabulary that we're going to discuss besides axis of symmetry, we're going to be talking about the x-intercept. You always set y equal to 0 to find that value. There's a couple of different ways to do that. To find the y-intercept, you set x equal to 0. To find the vertex, we have two ways that we're going to talk about how to do that. And most importantly, you've got two types of equations. You've got the standard form and the vertex form, and you're going to be going back and forth between standard and vertex form. This one right here is definitely more used than the second one. I definitely see this one more in textbooks, on the SAT. This one is more user-friendly, so we like this one a little bit more because it's easier when we complete the square, but it's just taking that k and moving it over to the other side, and then you have the other equation. We're going to start off first by just discussing what the y-intercept, or how to find the y-intercept, and basically you set that equal to 0. The y-intercept is where your parabola is going to be crossing the y-axis. So if you set x equal to 0, then you would have a point, x is 0, and then this would be gone, that would be gone, and you'd have y is equal to negative 12. And basically what that means for your graph is that if you draw a graph and you have 0, negative 12, I'm not saying that's the vertex. I mean, sometimes it's the vertex, but not in this case. This is just an intercept, meaning your graph is going to cross that. Your parabola could look something like that, or it could even look like this. It just depends. And you won't know that unless you start graphing. For this problem right here, if you set x equal to 0, then y is equal to 3. And, for this one also, you've got 0, 3. So again, your graph could be that way, or it could definitely be that way. For this one right here, when I set x equal to 0 and y is 6, this one's a little bit easier to see actually what this may look like. For example, I know that 0, 6 is my y-intercept. But if I'm looking at this equation, I'm thinking, oh, this does factor. And I know that factors to be x plus 1 and x plus 6, right? Which means that at negative 1 and negative 6, my graph actually crosses the x-axis, right? So if this probably would look more like this, and this would be more of an accurate graph for this parabola. For this one right here, what distinguishes this separately from the other three equations is that yes, we still have a y-intercept at 0, 3, but this value right here is actually negative, which means that my parabola is going to be upside down. It's going to look something like that. Also could go on that side, and we don't know, again, unless we start plotting some points. So let's take this equation right here and let's plot some points. I would like to just keep in mind, I know that this was a big topic in Algebra 1. You've already done this. We know our y-intercept, right? If x is 0, then y is 3. So right off the bat, I do know that we have a y-intercept at negative 1, negative 2, negative 3. So right here. Additionally, I also recognize that this can factor, and that's something that you need to keep in mind. Could I factor this like this, right? If I factored this, I'd have x here, a minus 3, and a positive 1. And then if I set both of those, this is going to go to 0 because then I'd be looking for my x-intercepts, right? Okay, so if I set that to equal to 0, then I'd have x is equal to 3 and x is equal to negative 1. So that means that at negative 1 and at, let's see here, 3, 1, 2, 3, that my graph crosses there for the x-axis. So that's just like a little intuitiveness before we start plotting points. So let's do that now. If I want to plot points for negative 2, I'm going to get negative 2 quantity squared minus 2 times negative 2, and then subtract 3. So what is that? 4 plus 4, that's 8. 8 minus 3 is 5. So I have a point at negative 2, so negative 2 comma 5. So 1, 2, 1, 2, 3, 4, 5. So right around here. At negative 1, if I plug in negative 1, I'm going to get negative 1 squared minus 2 times negative 1, and then minus 3. Subtract 3. I'm going to get 1 plus 2, 3. 3 minus 3 is 0. And at negative 1, I'm at 0. We already knew that. We already know 0, negative 3. Let's see what's happening at 1. So if I plug in 1, I get 1 squared minus 2 times 1, subtract 3. So I have 1 minus 2 minus 3. So negative 2 minus 3 is negative 5. Add 1 is negative 4. So at 1, I'm at negative 4. So 1, 2, 3, 4. So I'm right here. And let's see what's happening at 2. So we'd have 2 squared minus 2 times 2, subtract 3. So we have 4 minus 4 is 0 minus 3. So at 2, we're at negative 3. So 1, 2, 2, 1, 2, 3. So it does look like I actually found my vertex here at 1, negative 4. But realistically, we're just trying to graph this and did that. Okay, a couple of things. Yes, that looks like our vertex. Let's label that vertex. And that value would be at 1, negative 4. A couple of other things here. You see right there and there, those are called x-intercepts. That's where my graph crosses the x-axis, and I set y equal to 0, set y equal to 0. Right here is my y-intercept, and I found that by setting x equal to 0. And then lastly, something called the axis of symmetry, which is if I know my vertex is at 1 comma negative 4, the axis of symmetry is the x value, and it is actually a line. And so the way you write that is as a line. So like x equals 1. That's a line. And so you write that as an equation. So you would have x equals 1 right here. This is my axis. Oops. That's my axis of symmetry. And let's see if I can do that. There we go. Okay, cuts my graph in half. Symmetrical. Okay. So far, does this have a maximum or does it have a minimum? That's what you need to answer also. And if you see how it drops down low, this value not only is my vertex, but in this case, because it's the lowest part of my graph, it's a minimum. Additionally, the domain for this quadratic is going to be negative infinity to positive infinity. And my range for this quadratic would be negative 4 up to infinity. So write the equation in standard quadratic form. So what we have here is actually the other form, which is vertex form. But I want this in standard form. So I'm going to replace this with a y and to just start off with. And so when we go y equals, we have 3 times x plus 7. So this part right here, there is a little trick to solving that. If you don't know the trick, which I'm going to show you in a minute, you're going to have to FOIL. So that's going to be x squared plus 7x plus 7x plus 49, and then add 8. Before I add 8, make sure that you take care of this 3 in the front. So we have y equals we have y equals 3x squared. So 3x squared, and then we have 21x plus 21x is plus 42. And then we have 49. 3 of those is 147, 3 less than 150, so that's 147. And then plus 8, 147 and 8, 155. So we have y is equal to 3x squared plus 42x plus 155. And so now my equation is in standard form. Just right here, people, there's like a little shortcut. All right, I'm going to show you that while I'm here. The shortcut is we have this, right? X plus 7 quantity squared. So right there, this value right here. Square the first term is x squared. Square the last term, that's 49. Multiply 7 times x, that's 7x. Double that is 14. I just saved you 2 steps, that's all. So you could do that. That's, quick. Again, you square the first term, you square the last term, you multiply the 2 terms together. X times 7 is 7x, lost my x, and then double that, 14x. Okay. So let's try this again and put this in standard form again. And for this problem, let's do that. So we're going to go y equals 1/2. And let's do the little shortcut. 4x, so square the first term, so that's 16x squared. Square the last term, that's 25. Multiply the 2 terms together inside, so that's 4x times 5, and that's negative 20. And then double that, so that'll be negative 40x, right? There you go. So y equals half of 16, which is 8x squared, half of negative 40, so minus 20x, half of 25, I'm just going to say 25 halves, and then add 3. So I need to combine these 2 terms here. So I mean, like 3 and 25 halves, I could definitely do that. That's, 3 times 2 is 6. Add 25. So yeah, you could do that the way you do that there, but I'm just going to get a common denominator and multiply by 2 over 2. 25 plus 6. Oops. 25 plus 6 is 31. And so let's see where to put that. We go y equals 8x squared minus 20x plus 31 over 2. And now we are in standard form from Vertex form. So again, standard form is ax squared plus bx plus c. And Vertex form looks like this. Again, sometimes people do this. And the reason why they call it Vertex form is because they give you a vertex. And so, for example, here, the vertex is HK. So this is H, right? And this is K, HK. So you take the opposite of H here, right? So that's going to be 1, comma, and then this is 3. If the K is here, you don't take the opposite of that. But if the K is here, you have to take the opposite, right? It'd be 1, 3. All right. Standard form. Okay. So any questions on this regarding whether is the parabola going to be symmetric? Always symmetric. However, where the line of symmetry, that will actually vary. And so here we go. Graph the quadratic equation with the given vertex and intercept. So for these 2 problems here, you're just graphing. That's it. That's all you're doing. And so take a moment and do that, and then check your work. Okay. You can always start and stop the recorder anytime. So we have 1, negative 3. Here we go. That's the vertex. I like to put a V there. Just reminds me. And then I have a y-intercept at 5. So 1, 2, 3, 4, 5. So that's up here. So this graph, this parabola is actually really thin. And yeah, I know, do better. Okay, here we go. And then we have a vertex at negative 2, 1, 2, 6, 1, 2, 3, 4, 5, 6. Here it is. And my y-intercept is at 1. So vertex is here. So for this graph, look what's happening here. That's got to go through that. So a couple of different things. Number 1, I have a axis of symmetry. Write down, always cuts it in half, right? The axis of symmetry, if it's like a little difficult to see, the axis of symmetry is always that x coordinate. So it'd be x equals 1. the axis of symmetry here is going to be x equals -2, and we call it axis of symmetry. So if you ever see this AOS, that's what that axis of symmetry is. And remember, it's just that line, cuts that in half, just straight down like that. Talking about the vertex of the parabola, I did speak of it a little bit before, where we have this equation here, HK. So this is H. See how H is the opposite? See the minus sign there? That distinguishes it. K is just going to be the same. The vertex shortcut, though, is going to be, if it's in standard form, where it says y equals ax squared plus bx plus c, the vertex form you're going to use to find negative b over 2a, negative b over 2a. So you're going to find that first, and then once you finish finding that, you're going to plug that into the equation to find the y. So let me explain how that's going to work. We're going to find negative b over 2a. That's our job first. So right off the bat, negative b. So let me see if I can make, there we go, a little bit bigger. And so what we have here is the opposite of b. That's negative b. So that's going to be 5 over 2 times a. A is 2. Okay? And so what I have here is 5/4. So I have 5/4. And so now what I need to do is plug that into my equation. And yeah, you can do that by hand, absolutely. Or you can definitely use your calculator. So I'm going to use my calculator. And so I'm going to click on that. I've got my little calculator popped up here. And so plugging that in, ooh, I need the equation. Where is that? 2x squared minus 5x minus 6. So here we go. I'm going to put my glasses on. Okay, so what I need to do is plug in my point that I've got so far for that first one that was negative b over 2a. So I'm going to go 2 times the quantity, 5 over 4, so 5 divided by 4, close that, square that, so I need to put a square value on there, minus 5 times, again, 5 divided by 4, close that, minus 6, and then hit enter. And so that's my b value. So that's going to be what? Negative 73 over 8. So let's go back to this value here, and we have, what did we have? Negative 78, negative 73 over 8. So this would be comma, negative 73 over 8. Now, just a note, you definitely can check to see if this is, is this right? Did we find the actual vertex right? Because we have the actual equation. So let me go back to my calculator and let's see what this might look like. If I type this in to, I'm going to go menu. Nope, I don't want that. I'm going to go escape and close this. I don't need to save that. I'm going to go to graph and I'm going to type in my equation, which is 2 x squared, and I'm going to type in squared. Don't get caught up on using different letters, because if you see the x on the f of x, you need to use an x. Minus 5x minus 6, and graph. Okay, so now there's my parabola, right? So I need to move this up and figure out what is this value down here? How do I find that minimum point? And so there is a way to actually find that minimum point, but the actual, the realistic goal for this is to try to be able to, does this look approximately right? 8, does it look like I went down about 8? Because my vertex was at what, negative 73 over 8? And so that's what you're asking yourself. Does it look like that's 73 over 8? 8 goes into 73 8 times with some remaining stuff. But does it look like that? Yeah, it kind of does. So we are going to try to find where that vertex would be on my calculator. So the way you're actually going to go about trying to find, the vertex is I'm going to go to menu. And on menu, I'm going to go to analyze my graph. And I know that for this parabola, it's actually at a minimum. So I'm going to click minimum. And I know it's going to be in between. I'm going to just like click on that and move it over to here. And look, there I am. There's my minimum. And actually, it's 1.25, which is 5/4, -9. And then I think about it, 8 times 9 is 72. And yes, it's about that. So that's how you find that on your calculator. It's pretty cool. Okay, so moving on. So we have the right answer here. We're talking about the axis of symmetry. What this does is this tells you that the axis of symmetry is always going to be the x coordinate. Now, if they give you the vertex form, right, and we have our point, the point that they gave us here was 1, 3. So I know my axis of symmetry is going to be this h value, right, hk. So it'll be x equals 1, and that's the line of the axis of symmetry. But if you notice right here, it just says h is equal to, because that's the h value. So the h is equal to the axis of symmetry. Whereas here, in the standard form, the axis of symmetry is harder to find. Of course, if I had my calculator, that would definitely work. But if I don't have my calculator, I would need to be able to, figure out where my vertex would be on my calculator. So on a TI-84, let's just, show what that would actually look like on one of these calculators. Yes, definitely we're lucky enough to see that on both calculators. So we have 2. I want you to see this button. See where it says xt theta? You're going to hit that button right there. That's going to give you an x. And then you go down to this left part here. It's going to give you x squared. Click on that. Then you're going to go minus 5x. I'm just using the same equation that I did before. Oh, I hit delete, starting over. So 2x xt theta. See, you know what I did was I hit just x on my computer, whereas on the TI Inspire you can just hit x, whereas on this you can't do that. Okay, so 2x squared. So we go down here, and then we're going to go minus here 5x again, xt theta. And then minus 6. So minus 6. And let's see what happens. Oh, I can't hit enter because then that'll go to the next screen. But on these calculators, I believe you hit graph. There we go. Now I need to figure out what this value is down here. I know that I can hit the trace button. And by hitting the trace button, see there's like blinking button here. If you move it to the side, it'll actually go down. Looks like it's about 1, right about there. That's about it. That looks like my value. I believe that you can do something very similar to this. I know that it does have a table as well, so I could also try to find the y, how low it goes here at 1. It looks like it's at -9. It's about that. I mean, it doesn't give me the fractions, right? Because I know that I have 5/4, but it doesn't give me that in between. But you can get definitely an approximate value of what that vertex is. All right, so moving on. So finding the vertex by using the shortcut formula, this is just, again, -b over 2a, and then you plug it in. So this, some people put the a's on the side, like a is 1, b is -6, and c is equal to 8, right? And so we have -b, so we're going to go the opposite of b, which is 6, over 2a, 2 times 1, comma, and then I have to plug it in. What do I plug in? I plug in whatever I got here. So this says 6 over 2, which is 3. So now I'm going to plug that in. And you could definitely just plug it in. So it's sort of like f of 3, something like that, is equal to 3 squared minus 6 times 3, add 8. And so we have new equation. We have f of 3 is equal to 9 minus 18, which is -9, add 8, which is -1. So 3, -1. And then, yes, you would graph this. At 3, -1, we would have a vertex. That's the vertex. I do have a y-intercept at 8, and I know that would be right around here. And so I could draw my graph for sure like this, going back up. And just note to self, you want to put your axis of symmetry in there, and that's going to be, and it's a line. It is an equation of a line. If you don't have the equation, you won't get credit for it. The equation is going to be the x-intercept, the x coordinate of the vertex. So you have x equals 3, and that's my axis of symmetry. So far, that's what we got. So moving, yeah, and I mean, yes, we could just put that in there like that. So now we're going to try to move towards completing the square. We're trying to complete this square. And just starting off, remember how to square a binomial, right? And the long way, x minus 3 times x minus 3. Use the FOIL method. You've got x squared minus 3x, and then add 9. So basically, you're adding 2 of those, right? X squared minus 6x, and then plus 9. And, you know, definitely this is one of those equations that, you know, is on the SAT as well, because, you know, x squared plus 9, a lot of people think that that's the right answer, but they've lost the middle term. And, you know, that's one of those things that is absolutely incorrect. So just be very, very careful of that. So I'm looking at this. This is how I'd square. If I was squaring this, however, x minus 3 quantity squared, I would go square the first term, x squared. Square the last term, plus 9. Multiply these two together. So negative 3 times x is negative 3x, and then double that is negative 6x. So, you know, you save 2-ish steps, okay? So completing the square, though, is what we are doing here. And I want you to notice a couple of things. Notice that, yes, this is 9, squaring that last term. Also, multiplying this by a half. You know, you're doubling that, right? So we are going to be completing the square where you're basically taking half of the b term and then squaring it to find that last value. So like if I asked you, I don't know, x squared plus 4x. This is my b term. You're going to take half of that b term, which is 2. You're going to square that, and that's 4. And you're going to add that to that last term. And what we just did by taking half, and it's all written out here, but taking half of the b term, taking half of the b term, and then squaring that value. That's the big deal. That's what it is. That's how to complete the square. And so what they're saying is that you have actually forced this to be a perfect square. That's what you did. And so that's what we're going to do. So just practicing to complete the square. X squared minus 18, half of this term, that's my b term. Take half of that term, and that's negative 9, and then square it. And that's going to be 81. And what that means is if I actually completed the square correctly, again, let me just say that again. We take half of the b term, and then we square that value, and then we add it to both sides. Okay, those are the steps. And if I did this correctly, then I would be able to factor this like that and then have a perfect square, because I've actually forced this to be a perfect square. And these fractions make everybody a little crazy, I think. I don't know. But half of this term, and don't leave it without decimals. Just say half of 7 is 7 halves. And then square that is going to be 7 halves times 7 halves, which is 49 over 4. Okay, so meaning if I were to factor that, right, I would have x plus 7 halves quantity squared. That's what that would factor to be. And so that's what you're doing. You are forcing this to be a perfect square. Okay, so here we are. We have an equation. It's a quadratic equation. A couple of things that we do know. Number one, we know where the y-intercept is. The y-intercept is at negative 10. So we have a y-intercept at 0, negative 10. So I'm going to put that in right away. That's my y. That's not my vertex. That's my y-intercept. Now, I want to find the vertex. Yes, I could find the vertex by the shortcut method. But you do need to know how to find the vertex by completing the square. So we're going to do that. Now, we are going to then see this negative 10. I'm going to move that over there. So that is out of my way. Now, it's a little bit different than completing the square when you don't have an equation. Because on the last screen, those were just expressions, right? It wasn't y equals. It was just an expression. So for these problems here, because it is an equation, it's slightly different, okay? But the rules are the same. You take half of the b term, so negative 6 divided by 2, half of that term. square that value. So we have negative 6 over 2, which is negative 3. And then we're going to square that. That's 9. Now, because it's an actual equation, this is what makes it different. Because it's an equation, equations have that big equal sign in the middle, right? Which basically is a heads up saying, hey, if you're going to do something fun and on the right side, then you've got to do the same, give the same happiness to the other side, right? So if I'm going to add 9 to this side, because it is an actual equation, I have to add 9 to the left side as well. Okay, so now adding up the values on the left, I get y plus 19. Adding up, or factoring the values on the right, I'm going to factor that, right? And so I'm going to get x minus 3 times x minus 3. And just note to self, okay, it is always, always, always going to be the same value if you completed the square correctly. Because the whole purpose is to find a perfect square, right? So that should be 2 of those. Now, the last step to put this in actual vertex form, which is right here. See how the k is on the other side? We're just going to move that. So y equals x minus 3 quantity squared, and then minus 19. Which means that this is in vertex form, okay? Vertex form. And what that means is that my vertex is at positive 3, negative 19. So the way it is for this way is that you take the opposite of this term, but the same of that term. But if you were on the, if you left it in this form, it would be 3, negative 19. So you take the opposite of both. So my vertex is way down here at 3, negative 19. All right, that's the vertex. I always put a V there. And then you would graph it, hey, it's going to come up this way, and it's going to come up this way. And I didn't ask you where your x-intercepts are, but I am going to ask you for the axis of symmetry number 1. And so that's going to be x equals 3. That's my axis of symmetry, AOS. But I am also going to ask you for this. This is called a symmetric point. You need to know how to do that. A symmetric point is based on my axis of symmetry. That is at, where is it at? It's at 3. Okay, so there's 3 right there. It crosses through at 3. So my axis of symmetry, which cuts that graph into 2 equal parts, is going to have a symmetric point. But the only other point that I know right now is this one right here, which is my y-intercept. And this value here is 0, negative 10, which means then that if I went 3 over to get to my axis of symmetry, I'm going to double that and go another 3 over to get to my symmetric point, which means I'm going to double my axis of symmetry. So it's going to be 2 times the AOS, right? That's my x value, comma, my y-intercept. And that's actually the symmetric point. So 2 times my axis of symmetry, so 3 times 2 is 6. So I went over 6, and then down my y-intercept, which is 10. So this is going to be 6, comma, negative 10, and that's my symmetric point. All right, that's all we know about this so far. Okay, next let's do this again. We're going to name all of this fun stuff. We're going to first move this 1 over to the other side, although I do see that that is my y-intercept. And I'm going to make my graph just a little bit bigger. That is my y-intercept right there at 1. So I'm going to find the vertex. I'm going to move this 1 over. I get y minus 1 is equal to x squared minus 3x. Again, you're going to take half of the b term. So I'm going to do some work over here. So I'm going to take half of this term, and then I'm going to square that. And whatever I get, I'm going to add to both sides of the equation. So I get 9/4. So I'm going to add 9/4 here, and I'm going to add 9/4 over here. So on the right, I should factor this, and it's going to be a perfect square. It's going to be x minus 3/2 quantity squared. And on the left, I have to do some work here. Looks like I need a common denominator. And so 9 minus 4 is 5/4. And, excuse me. And so we have 9 minus 4 is 5. So we have y plus 5/4. And that's it for that. And so my vertex we have this in vertex form, is going to be 3/2, comma, -5/4. It's negative because I left this 5/4 over here. To put this in complete vertex form, then what I would do is move that over. So I'm going to go y equals x minus 3/2 x squared, and then minus 5/4. So the vertex is opposite of this term, same of this term when they're like that. And let's just, for fun, let's just graph this and see what this actually looks like. Okay, so I'm going to go to y equals, and I'm going to delete this equation. Okay, and let's type in our new equation. And it looks like our new equation was x, oops, got to do x t theta x squared. That looks like the squared button. And then minus 3, and then x again, x t theta plus 1. And to graph, you don't press enter, because if I press enter, I'll just show you what happens. I go down to the next level, because I can like put 2 graphs on one, which is very cool. And so what I would do is hit the graph button, which is up at the top, and there's my parabola. And if I want the actual intersection point, I would do the same thing, and I would probably just use my trace button. If it's not, these look like they're fractions, so I mean I'm going to get pretty darn close, right? I'm going to use my trace button. I'm going to arrow it over to try to get pretty close to that, you know, bottom value. It's like right there, right? It's right in between there. So yeah, you definitely can find it. It's not as accurate as the TI Inspire, which kind of narrows it down to find the minimum. I bet this will do that. Something like, let me play with that a little bit, and I'll get back to you guys on that. Okay, so moving on, convert to vertex form. So here we go. Now, I believe that there's one rule, though, before you can change something into vertex form from standard form. And the one major rule is that value right here, that A value, has to equal 1. And it's not, it's a 2. So in order for you to complete the square, you have to do a little bit of manipulating here. All right, so we're going to do that. And by the way, it's got to be a positive 1. So first off, I'm going to move that 7 to the other side. So I'm going to go y minus 7 is equal to 2x squared minus 20x. You're not going to just go through and divide by 2. What you are going to do is you're going to factor out that 2. And by factoring that 2 out, now my x squared is 1. And this also is going to help us in a later section, which we call conics, which is super fun. And so here's my x squared now is 1. So I'm going to complete the square, which is -10. So I'm going to take that b, -10 divided by 2, and then I'm going to square that value. So -10 divided by 2 is 5. 5 squared is 25. Now, the unique thing about factoring out a 2, right, is that like it didn't go away. It's still there. And because I took it out before I completed the square, then I actually have to put it back in before I add the same value to the other side, because remember, this is an equal sign. So I need to put that back in. So this will be 2 times 25, which is 50. And so what that's telling me is, here we go, y plus 43 is equal to 2 times the quantity x minus 5 quantity squared. So we have y equals 2 times x minus 5 quantity squared, and then subtract 43. So there's my vertex form. Okay. My vertex is 5, -43. So that's like way down there. So like down here, my y-intercept is way up here at 7. So, you know, yeah, my graph is going to look something like this. I am going to have an axis of symmetry right down the middle. And that middle value is 5, right? And so that's going to be axis of symmetry at x equals 5. So the other thing is I need a symmetric point, right? So to find the symmetric point, I find my y-intercept, and I just go straight across there. So if this was 5 going that way, this is also 5. right? So my symmetric point would be here, and that would be 10, 7. There we go. So far, so good. All right. Complete the square to find the vertex. Again, moving the 11 over to the other side, we're going to get y minus 11 equals negative 3x squared minus 24x. And then again, you know, note to self, this is like, you can't have that negative 3 there, so we're going to have to factor it out. I already know my y-intercept is at 0, 11. Okay, so let's factor that out. We're going to take out that negative 3. Negative 3x squared here. If I divide out a negative 3, this would be positive 8x. And then I'm still on the left side at y minus 11. And, you know, I get that, you know, not everybody's like super savvy as far as factoring values out. But just keep in mind that when you are actually factoring, you know, factor means divide. So that's like divide by negative 3, divide by negative 3, right? The negative 3, that's a 1 here. And then negative 24 divided by negative 3 is 8. So that's, you know, that's kind of like another way to think of it is factoring means divide. Okay, half of 8, so let's complete the square. Half of 8, and then take that value and square it, and then add to both sides. Okay, that's what I'm doing. Add to both sides that value, because it is an equation. So 8 divided by 2 is 4. 4 squared is 16. So here I'm going to add 16 on the right. Here I'm going to add 16 on the left. Not 16 on the left, right? Okay, I hope you caught that. Definitely not 16 because, hello, do you see this negative 3? I took that out. Before I add it to the other side, I got to put it back in. So I'm actually adding negative 48 to both sides. Okay. All right, so here we go. On the right, we have negative 3 times x plus 4, quantity squared. On the left, I get y minus, it looks like 59, right? So that would mean y equals negative 3 times x plus 4, quantity squared, and then add 59. This is my equation in vertex form. Definitely, you need to know that. And your vertex is going to be negative 4, comma, positive 59. And, you know, I would just check that, absolutely, double check that. I'm going to use my calculator. Let's see. I'm going to use the Inspire for this one, just switch things up a little bit. And let me put the actual equation in to the Inspire, and let's see how we go. Put my glasses back on. Okay, so I'm going to close this out for this problem. I'm going to go graph, new document. I want a new graph. Gives me this. I'm going to type in negative, so I've got the negative 3, and then I'm going to go x, t, theta is all down here. So we've got x. Where's x? X. Donde? Oh, there it is, x. Squared. So we're going to, oops, there it is. X squared, and then move the arrow key. Oop, oh boy, not done with this. Okay, so then we're going to go minus 24x again, and then we're going to go plus 11. Let's see what happens. Okay, it looks like I said that the vertex was at negative 459. Let me just drag my screen up a little bit and see what, oh, this is way up here. You know, what I think I would do even is, let me go to my menu. Let me look at my window. And I would go, you know, you can definitely zoom in and out, but I can also change my Windows settings. Negative 12 is fine. The max, though, I want to put my max for my x-axis. I guess I'll just make it, because it's over to the left. I'm going to make that like 8. But on the y-axis, I know it's at, what, at 49 or something? So let's just make that, let's say 50. And, oh, that's my minimum. Let's make the minimum, I don't know, negative 10. And let's make the max, though, let's make that, I don't know, 55. Let's see what this does to my graph. Oh, makes it a little bit better, doesn't it? Okay, so there's my graph. for this equation, yeah, that looks like the same one. What I would do at this point is I want to find my vertex because I want to make sure that I've got it right. This, I don't know that this has a trace feature, but I definitely can go to analyzing my graph, and I want to find, this is a maximum because it does this, right? And so I'm going to find my max value. So I'm going to move it to the left. I'm going to click once. And then what that does now is going to move to the right. And look at that, negative 459. That's my max point. Right on. This is perfect. Okay, so we've got the right answer. We're all happy about that. And let's move on to the next question. We are going to complete the square one last time. And the reason we're going to do this problem is because this is a negative. And by far, this is the most missed kind of question that you're going to get. Because when you're trying to find the vertex, the negative, you can't have that there. So even though this looks like a pretty simple equation in relation to the other ones that we've done, this is a little bit trickier. So we're going to go y minus 10 is equal to negative x squared plus 12x. So we have to take out that negative sign. So in order to complete the square, negative has to go. So this stays here. We're going to go factor out negative x squared. So there we go. And then when I factor out a negative sign, this is where people make mistakes. This is a negative here. So that's going to be negative 12x. Half of 12, okay, let me go over here. Half of 12 is 6, negative 6. But when I square that, it's positive. So I've got negative 6 squared, which is 36. So that means I'm going to add 36 to both sides. So add. So I'm going to add 36 here. Now this is, again, another option for making a huge error. Do you see this minus sign? That's minus 36. So we're going to be adding negative 36 because, you know, even though we're taking out the value because of that one little rule that the x squared term has to be positive, even though we're taking that out, in order to add something to the both sides, you know, it's got to be the same value. And what I added was actually a negative 36, and that has to go to both. So here we go, y minus 46 on the left, negative, and then factor this, right? X minus 6, which is x minus 6 quantity squared. And then putting this in vertex form is negative x minus 6 quantity squared, and then add 46, so that it looks like, you know, for sure my parabola is going upside down, right? Because it is negative. Going back up to the top, I do have a y-intercept at 10. My vertex is at 6, 46. So over 6, up 46, way up here, and put a V there. 6, 46, which does lend to 46. Okay, I can't write that. Which does mean that when I do this, this is happening, right? Like that. And then I do have my axis of symmetry right here, that where this is 6. And then if I want my symmetric point right there, that's 6. I got to double that, right? So that point's going to be 12, comma, and then I went up 10, so that'll be 12, comma 10. Now, I know this says to verify my vertex using the shortcut, so I can do that, or use my calculator. But let's just do that because they asked us to. So negative b over 2a, so parenthesis. Remember the vertex? It's negative b over 2a, and then plug that in, negative b over 2a. Okay, so negative b, so that's the opposite of 12, so negative 12 over 2 times negative 1. Negative 12 divided by negative 2 is 6. So here we go, 6. And now I got to plug it back in. And when I say plug it back in, you go back to the original equation and you plug in 6 for wherever you see an x. Okay, so we're going to go the opposite of 6, let me do that like this, squared, plus 12 times 6, add 10. Okay, so that's going to be negative 36 plus 6 times 12, 72, plus 10. I'm going to use my calculator. Negative 36, add 82. Is that right? I got 46. Oh, good. I always like it when we get the right answer. Okay, so that's my vertex. Again, just verifying it another way. But, hey, use your calculator. Your calculator is your friend. You all are going to be taking assessments, whether it's the SAT, the ACT, the SAT 2, subject test, which I talked about to you guys already. You're taking these. That calculator is your friend. You need to get to know whatever calculator that you're using. That needs to, like, you've got to bond with it. You need to be going to that for all of your problems, right? Yeah. See my double on trying. Okay. Anyway, learning targets. We did this. We plotted quadratics. We talked about the vertex. We talked about putting it in vertex form, and we found the y-intercept. We also found the axis of symmetry and even a symmetric point. So good job for everyone. You have a homework assignment page, it's 180. It's quite a few problems, but they are odd on the right side. I think on the left is all, because it's pretty simple. It's like complete the square. It's like one number. Pretty simple. I want to talk to you about this super cool negative parabola that I saw when I was in Scotland, and I took a picture of this, and I was taking pictures of parabolas all over the place, so I'm going to be sharing that with you. Thanks so much for watching, and I hope you have a wonderful day.